So first we have to finish up chapter 3, and then we have to do all the review for the midterm. So we're going to graph some more complicated things, and luckily, no matter what happens, when it says graph, I know I'm just going to pull out the calculator and put it all in there, so I don't have to use all this, the traditional way of doing this, all this calculation and stuff. But these concepts are in there, so let's kind of go over them. Vertical asymptotes. Now, we did like a 1 over x at some point, and it looked something like this. And then the graph on my calculator it looked like a heartbeat on it. It went like that. And I'm like, well, what does that mean? And I said at the time that there was this dotted line here. Okay, my calculator filled it in. Some of the more recent calculators don't, but it might look kind of like that, filled in or not. But either way, that line is the asymptote. It's not actually part of the graph. It's just saying that the picture gets closer and closer and closer to the asymptote and never actually touches it. Okay, it doesn't look like that the way my calculator does it, but that's what's supposed to be happening. It's supposed to get closer and closer and closer to that. And there's a reason why those occur. And it occurs anytime the denominator is 0. Okay, in this one right here, if you go, well, you can plug in anything you like. I don't care. Go ahead, plug in anything. There's always going to be one wise guy who suddenly says, all right, then I'm going to plug in x equals 1. And then you're going to be, let's see, 2 times 1 over 0. Well, I know not to make the denominator 0. When I said plug in anything you like, I meant anything besides that. Of course not that. Okay, and the reason why you can't is because it makes no sense. You can't divide by 0. And that's where the asymptotes are, right where you can't divide by 0. So the way to find vertical asymptotes is to set the denominator equal to 0. That's anytime you see the words vertical asymptote, that's how to do it. Set the denominator equal to 0. X minus 1 equals 0. X equals 1. Or if this is it, I have to set that denominator equal to 0. X squared minus x minus 2 equals 0. So, well, I'm going to have to factor. Okay, I'm just going to unfoil this one. I got to use 2. So 1 times 2, if I go with minus 2 and plus 1, that's going to give me negative 1x. Minus 2x plus 1x is going to be negative x. Okay, then set both of those equal to 0. X equals 2. X equals negative 1. So if I had put this in my calculator, that's where I would have seen those 2 heartbeats. One of them is at negative 1, and one of them is at positive 2. And that's how you do this.